There we go. Okay, I don't have any, we're not going to be learning any major new concepts today. I'm going to talk a little bit about some high-level concepts of programming or computer science, leave time open for questions, ask if there's any topics that we've learned or concepts that we've learned been a challenge for you so far. Maybe we can review those either now or in the next class, and then probably get out of here a little earlier than normal. But let's start off like normal, and let's go over the homework. And we may not go over all of it, but we'll go over at least some of it. Maybe work a couple in class. Who here looked up what reverse returns in the Ruby documentation? Yeah? All right, what type does reverse return?
It reverses the array. Well, it reverse actually makes another separate array that's got everything reversed.
Okay.
Reverse with the exclamation point actually reverses
the array. Okay, good. Yeah, so I was going to ask, the difference is reverse itself returns a new array, reversed version of the original one, whereas the reverse with a bang or exclamation mark at the end, either term works. You'll hear bang used in programming a lot. Reverse with the bang actually reverses the array that you started with versus giving you a new array. So we can look at what that means. What's the difference between the two very easily. If we have an array, 1, 2, 3, oops, get rid of that K. And let's look at the object ID for that array. Then let's do array.reverse. Let's put this in something. If we look at that, we see that they don't have the same object ID. We get a new object back. I hope Ruby doesn't betray me here because this should work. What we can see here is that this is the same object that we originally had when we did the bang version. So our object ID didn't change when we used the bang. That is going to be another convention you'll see in a lot of Ruby code where a bang version of a method will change that object directly, particularly arrays, and the other version may return a new object instead. Now, one thing that's interesting about it is the reverse bang, it does also return a reference to the reversed array. So it doesn't just change it in place and not return nil. It still returns a reference to the reversed array. Okay, let's see what else. Does anyone have problems with this first set of practice assignments? Figuring out what these do? It should be pretty straightforward. The one that might be a little tricky for us is this mult_add inside of it. Does anyone know what the result of that is? 10? Yep. And once again, you can just break it down. Okay, I do this add first, which gives me 2. And here I do add, which gives me 5. And those become the arguments to multiply. And that's a useful skill when you're looking at any code, is to break it down bit by bit as you're thinking about it. So writing methods. Let's see what we have here. I got to review these assignments. Sum and product. Write a method that takes one parameter in an array and returns the sum of all the elements in the array. Anybody have problems with that? That was pretty easy. Did people use the each method to go over your array and add everything up? All right. The product should be very similar too. How about this first and last? Who was able to finish this one?
I did it, but I wanted to know if there's a way, like, if people put in punctuation to filter that out.
To filter out punctuation?
Yeah, like if someone types a sentence and they put in like special characters while typing it, I can still pull out the first and last, but it adds the exclamation.
Sure.
The sentence, you killed my father, prepare to die. And it returned the die with the exclamation point.
What you're saying is when you did this, you get back this guy with the exclamation mark on it.
And the comma, like, how do I get that?
And the comma.
Yeah. The comma after father.
Right. Well, we could get rid of them if we want to. We've learned most of the tools that would allow us to do that. So we could, either working off the original string, we could go through the string and look for any characters that we've decided are punctuation and compare against those. That would there's different ways you could do it, but that would look similar to, let me see. Make this larger too. There we go. So if we have a string, we could walk through each individual character in it and strip out punctuation by getting, say, the length. I'm walking over it one character at a time and comparing it against if we have, let's create an array of punctuation. Our punctuation might be comma, period, exclamation mark, question mark. There's gonna be simpler ways to do this, but this is, I'm trying to build with just some tools we have. What's some other punctuation? Semicolon?
Yeah.
Colon. There we go. So let's, I'm not necessarily going to write it all out. Maybe this will be an assignment at some point, but let's sort of pseudo code is what you'll call it when you're not writing something out completely, but you're placeholdering it. This is the way I would actually write this if I was doing this myself, is I'm going to usually write it out in comments first. So I'm going to write something like, would be one way you could do something like that. And would take a little bit of work. In fact, you're probably going to have some gotchas that are going to hang you up if you try and do that. Some mistakes that you might make. You could also, let's pull up the, yeesh, it's ugly. All right. That's not what I'm looking for. Let's do this. We'll jump over to arrays and then go up from there. Core. And I'm looking for string. And I might, if it was me, I might be lazy instead of trying to write it from scratch and try and see what we've got here. So maybe there's something else we can use. I don't know. Looking for it. I don't know what they're going to call it in here. I'm sure it exists though. Where is it? What am I looking for? Yeah, I'll have to look for it later. What I was trying to find, but there's going to be something in here. That'll let you find, I'm pretty sure there's going to be a method on a string that'll let you find something that matches in the string, something else. So in that case, you could iterate over your array of punctuation and look for anything matching in your string and pull it out. And you could even, to really hack something up, this doesn't work perfectly, but the strip or split does some work as well. So we could do and let's say we could run this on each one, but I'll do it against the last one here, for example, which is 7. Oh wait, 6. See?
Oh, yeah.
Now, this only works because I know when I'm trying to get off of it, but split is a method that can take arguments as well. So you could run through and split on the individual punctuation you're looking for, and if it's at the, it'll rip them out. It'll essentially create a new array. What it did was I got a string with this portion, and then I split it on the exclamation mark because I knew that's what I wanted to split on, which returned a new array with just the word in position 0, because I told it instead of splitting on a space, which is what we've been doing by default, I split on the exclamation mark. So maybe I'll make that an assignment, but I think it's a little tricky. There's a few edge cases and gotchas that make it a little hard to easily solve.
What I was doing is probably making it difficult. I read it as in I wrote it so someone can actually enter the sentence. They can enter whatever sentence they want.
Right.
And it'll, find the person to last. So I did it so they can put in a full sentence within a full. Oh, I can though, instead of sending it straight into an array, they put in a sentence and then it makes it directly into an array.
Yes.
The way I did it, but I can put that down and then do the cleaning to actually just have the actual string first and then split the string into an array.
Yeah, you could do it in a lot of different ways. You can clean up the string first if you want and then split it. You could split it and then clean up each individual string that you get out of there if you want to.
But I mean, if I do it that way where it makes like individual words each their own array, then I have to put them back into if I'm not doing it.
Yeah, you probably have to. It depends on the way that you do it, but yeah. Yep. Okay. That was a good one. Some good questions. I don't think immediately we will try and tackle that because it adds a fair bit of complexity to the assignment, but it might be something we'll do pretty soon.
Also downcase because it will, I guess there's probably another way to do it. I did downcase so that it would just alphabetize it and not put variety on a capital letter versus lowercase. But there's probably another way to sort it where you tell it to sort it specifically in alphabetical order, right?
I think I'd have to look at how Ruby does that. I think I was playing around with Ruby just the other day, and I think that Ruby is smart enough to sort uppercase and lowercase together.
I was funny, or maybe
But I could be wrong.
Down, but it took the capital B and put that as the first.
So let me try here. That's not what I want. Nope, yeah. It looks like it doesn't.
Yeah, it puts it as priority, I think, for the capital.
It's not based, I don't think it's based off the priority of the capital. It's based off, it doesn't need to get into, but it's based off the character code of it when it's converted to a number when it's encoded. And so this isn't accurate anymore. Nothing's actually ASCII. A different encoding than ASCII. But what you'll see is if you're going to the numbers that they ASCII are in the system, all the capital letters show up before all the lowercase letters numerically. And so that's how it's a coincidence that the capitals are first versus the lowercase. It's not an intentional make capital letters sort first. Okay. It's a fun one. That was tricky. How about string joining? Who was able to tackle this problem?
I did. The person asked.
Write a method that takes two parameters, one array and one string, and returns one string with the second string between each of the other strings. Yeah, that's good. Okay. Did anybody else tackle this one? No? You want to try and solve it together?
Yeah.
All right. What is this again? Oh, man. Join. Write a method that takes two parameters, one array and one string, and returns one string with the second string between each of the other strings. Okay. So join is going to take an array and a string. Any suggestions on where I start? So calling it will look something like this. We got a suggestion on where to get started at? Nothing?
Okay. I think what we should do is then use the push method to add.
So you did array.each, right?
Then I put inside. I just named it inside.
Right?
And print the value inside. Value with the push. Well, I use the less than signs. Right? I don't know. I like the way that looks. And then I did it in the to make it. I made it a string. So inside of the quotation marks, the backslash s to tell it to put them, add them together as a string with the space between.
What do you mean?
Of the backslash s to put a space between each item, so they won't be just all on top of each
So you did this? Okay.
other. So I actually did. So then you can add it to the string. I think it's wrong. Is it supposed to end up being a string?
Yeah, I'm supposed to print out one string.
Okay, so then that's fine, because that's a string now. Your array is a string now, and then you can add the string together. That makes the
Oh,
array a string.
so wait, you want to do, what else am I doing?
You can add the array, add the string, append the string to the array. And then after n, print the,
So how am I appending the string to the array?
with the less than symbol.
So now I'm doing string. Is what you had?
I did it with both of them being an array. And so I didn't do the array comma string. I did it with it all being an array, and I just did it with the s backslash. So I feel like it's wrong.
Oh, you didn't have a second string. You just, what you did was you took one argument. Is that what you're saying?
Yeah.
And just concatenated them with a space in between?
Yes.
Okay.
So I know it's wrong, but I think if you actually make that all work with maybe turning the string into an array first, and then adding them all together, put them in a container together, and then do that same code with the space.
Maybe.
So like when you get and before the def joins to turn the string into an array and then add them both together,
So this has us put whatever is in this other one there. All right. So let's do it this way. Let's pass the space in between it. Start with one that looks like this. All right. So we want to get that space in between each word. Let's have more fun. Let's make this more interesting than it was.
I do know my method will make the array a string. With space in between.
Right, there we go. Does anyone have an idea where to start? A little tough? What about,
Do you have to create a separate string to store all the values from the other? So you're trying to return a string, right?
yeah,
So you need to create a string in which you will add all the values of the array with the space, if you will.
sure, okay, this sounds, so let's create a string.
So
Uh,
that's called a word.
combined, right? Let's create a string, all right. We've got an empty one here.
And then inside the loop, you say combine, and then do the less than value.
No, I don't know if that works, but we can try it. Here, let me test something.
Yeah, wait.
It looks like that works as a way to add something to a string. We also are familiar with the ability to do this, right?
Right. Plus value.
Plus value,
Yeah.
all right.
All right. But in the homework, they give you a hint.
We can try and return combined. So let's see what happens here. This is Scratch, right? Oops. All right, I've got my syntax wrong, don't I?
Yeah.
Where-
Each do.
Each do?
Yeah.
Yep. Oh, it might be a good idea to print this. Or puts this. Let's put that. We actually see something. What happens? All right, we're missing something.
Yeah, you're missing the space plus the string. And the combine plus the string.
All right. Sounds promising. Let's try with something other than just a space. Let's add.
Not a word or a comma.
Oh, it works.
Let's try space hello space or something. What?
Well, instead of doing adding it up to the print, you know, when I did the space in the parentheses, instead of adding it there, I did it below where after N I put print, and I told it to print the string that I created, but instead of just printing the string I created, I added the other string. I created a string out of the array, and then when I hit print, I said print that string from the array and print.
Do you want to take your code and put it into the Slack so I can
Sure.
see it? All right, let's try this now. It looks decent,
You don't want that
but
little at the end.
yeah, it looks like we have something.
Yeah, that's where you need to use a net statement to check whether the value that you're evaluating from the array is the last one. If it's the last one, then you don't want to add that.
All right. Suggestions on that?
So inside the loop,
Inside our loop?
yeah, you would say if, no, above that one, right? If value is I'm lost now.
This is a tough one.
Yeah, right. How to check if that's the last one?
The last one is what?
In the array.
The last word in the array.
Last one.
Oh, the last word, the array dot.
Is there a method that would say?
Array dot last.
I was gonna say that.
Okay.
See now, Ruby is so flexible.
Let's try this. So if it's what do we want to do in here?
If it's the last one, actually, it should be the opposite. While it's not the last one, you need to do the command.
All right, hold on. Ah. I can never remember this keyboard shortcut, and I always try and learn it. And there we go. Okay.
If it's right, I did it. If it's not right, I didn't do
So let's see what we have now. I missed something, I believe, again. Okay,
Two ways.
there we go. All right, what do we have? Hello, hello, my hello, name hello.
Missing is.
I am missing is. Because we dealt with one case,
Yeah. If it's
but we're doing this with both. So we could do this. That way we're adding the value in, and then we're only adding the string if it's equal to the last one. Ah, evil. I'm gonna throw a little kink in here.
space.
What's that?
It's mine is one word.
You notice what happened there?
Yeah, this and mine. They're together.
Uh-huh.
No space.
But I don't have them together here. What happened was our space hello space didn't go in between them.
Yeah, because did it get confused because isn't this the last element?
Yeah.
It's repeated. Oh, interesting. So instead of so we have to fix that if statement instead of using array last. No?
Yeah, this is yes.
So can we put the combined plus string before the become? Yes.
What do you mean? Oh, put this
From there.
down here.
Yeah. And then can you value the equal statement?
Delete this if statement.
Yeah.
Let me do this.
So
All right, let's see what happens with that. That's not quite what we're looking for because we only added it to once at the end, as opposed to having it between each word. And that's because it wasn't inside of our loop.
If you want the space, just send it combined with the space.
What's that?
Combined equals backslash s inside of the, right?
Well, I think the challenge we have right now is, can we,
Leave the f, the if value with the, that you were before. If you leave that as a comment, as a slash space in there.
so let's go back. I don't know if it's gonna let me. No. Why don't you let me redo? That's weird. So you wanted to bring this back down here? And then comment this out? And what else?
How about combined equals, but the backslash s between
Right here?
up at the top.
Oh, okay.
Right.
So what do we get out of that?
Why didn't you do that?
Well, I think the reason I did that here was,
Oh, yeah, the double.
yeah, that's stupid editor.
I hate this.
But that's still not what we want. So if we were going to walk through this, you could see that because here we started to create a string, and all we've done is put a space at the start of it. And then we go through our array. We have hello. That's our value. So now space equals space plus hello. Okay, let's go back up again. Now we get the next item out of the array is, because we didn't add anything else, is, okay, so combined now is space hello. So now it's space hello plus is, with nothing else in between. So we were very, I mean, this is definitely what we're going for originally, is bring this guy up, whoops, put him inside this if block.
So you have to change that if, right?
We do, yeah.
Yeah.
And I don't know, there's another case of, I'm not 100% sure I gave you the tools to do this ahead of time.
Did you see my method?
What's that? Review.
I just think it's like,
Let's see if my Slack will load. I'll snag that and then we'll look at it in a minute too. Oops.
sorry, I heard the sound.
Launch it out for now. Oops, I still have. So I actually don't know. It's partially my fault. I just tripped you up. I don't know if I gave you the exact tools to do this.
Would you mind going to the black screen? Because I want to try, I tried something here.
I can give you another way to do it. And yes, we do have the tools, though it's a little trickier.
So,
So-
maybe I'll get that easy.
That's a good question. So here instead you want to do,
It's a, yeah, object ID. Every class.
try that. I like it. I don't know if it works, but I think it's a really good idea. There we go. It looks like it worked just fine. So that's a fantastic solution to it, is using the object IDs. What?
What is that?
Because it's putting it between each word. If instead, I can change this to just be the space, but I changed it to hello so you would see the extra space that was showing up at the end very clearly.
Would you put a comma to actually see a little bit better than just the space?
Sure, I can do the comma. It's just inserting that second string in between each item in that original array. Another way you could solve this, that I think this is a very good solution, probably better than the other way. But the other way that you might see somebody solve that to not have it be the last one is you could instead say use a while loop, get the length of the array, and then iterate over it that way, getting each item out of the array using their index. And then when you're on the last index, just don't append that way. What?
What was that last part?
Adding in these object IDs. So what's happening here, and this is stuff, we'll get into it more, but as we dig into Ruby more, I've shown you a couple times that each object that you create gets its own ID. So here's a specific object ID. Now if instead I create bar, the same string, they're not the same item.
So these are the different orders.
Yes, yeah, they're different items in Ruby, which is why if I did bar 0, this is me being a little hackish, and I made it F, and then we looked at bar, it now says fellow world, but foo didn't change. It's because they're two different objects. And that's how he was able to use the object ID in this code to find out that it was only the last one, because this value, when it's the last, will have the same object ID as if I compare it directly to the last item in the array. But it won't have the same object ID as any other string that's the same in the array, because those are unique string objects. Yeah, it was tough. All right, let's see. Yeah, let's head on. We're getting late already, so let's go over the material I wanted to cover for class. There's not a ton today. I wanted to do the homework review, so I did a good job there. And then I just wanted to talk about higher level concepts of programming. Leave time for questions. If anybody has questions about anything that we've done so far, any concepts that have been a challenge for you, let me know. I'm going to take notes and make sure if there's anything like that, we will come back and revisit it in class and go over them again. And leave it open for any ideas for programs or other things that you guys want to do in class as well. So computer science or programming, it's not all about sitting down and writing code. If you're programming professionally, I would say that frequently 10, 20% of your time, maybe, depending on the day, some days it might be 80%, but maybe 20% on average is actually spent writing code, just writing something out, because a lot of time is spent trying to figure out how to solve problems that have been put in front of you. There's a lot of creativity, a lot of problem solving, a lot of different work in those venues that goes into most programming. It's not just sitting down and banging something out really fast on a keyboard. Brainstorming, yes. And there's certain tools and concepts that are helpful when you're trying to solve problems and thinking about stuff in terms of programming that really help you succeed or just help you understand different ways to attack some of these problems. That's what we're going to talk about right now. The first concept is abstraction. And I've got it up there already. I can't hide it. Oh no. Outside of this, can anybody give me a definition of what abstraction means?
I'm seeing it there. So.
Yeah, abstraction is hiding complexity by providing a simpler interface to something. This will happen. You interact with stuff all the time that does this, but it can solve a lot of problems. One is it just makes it easier to work with so that you don't have to worry about the internals. And also it's very common that you'll see something abstracted away so that instead of having to know exactly how it works, you can work to a common interface and it doesn't matter how it's implemented underneath. So to help you think about what abstraction means, what it is as a concept, I've got some real world examples. And one of the ones that jumps out to me immediately is thinking about a steering wheel in a car. A steering wheel in a car is an abstraction for a lot of stuff going on inside of that car. You have your linkage that's connecting your wheels, and you've got a set of gears that are going back and forth to turn the axle so that the wheels can turn and can move your cars in different directions. And in some cars, that might be an actual physical linkage. And a lot of cars, after the invention of power steering, it used the power from the vehicle to magnify your turning capabilities. So it's a lot easier to turn your car than it was in vehicles after that. That meant there's a lot more complexity going on underneath there. The whole way it worked changed almost entirely. And in some very modern cars, your steering wheel isn't directly connected to it at all. It's some sort of wire mechanism, just electricity that's telling it what to do, and you don't have a physical direct connection. And yet, through all of those changes in the way that your car actually steers, the way that we interface with it and interact with it hasn't changed. We still turn a steering wheel the same way that we always have, and it doesn't matter to 99% of people who get behind the steering wheel of a car exactly what's going on behind there. Most people are never going to be able to explain how all of that works or what the connection is. And that's one of the big benefits that you get through abstraction, is being able to hide a lot of details that sometimes you don't ever need to know about. And sometimes you just don't want to think about them now. So we're going to step over into Ruby. Can anyone give me an example of a concept that we've learned already in class that provides an abstraction for us? Yeah, exactly. Methods are one of the core ways that we abstract complexity away so that you don't have to know everything going on. You have a method that says find longest string, and instead of me having to worry about all the complexity of figuring out how to do that, it's abstracted down into this method, and I can just call into it and know that it'll work. And if I change how I find that string, it doesn't matter because I'm still talking to that same interface. Some other great examples of abstraction that we see, a video game controller is a good example. It's probably more direct because every video game works entirely differently. Hitting the X button on your controller or the square button or any of those, it doesn't do the same thing in any video game. And yet you can still use that exact same interface to interact with every single game that you interact with. It's another great example of one that you can definitely see the difference really quickly behind the scenes. And a web browser is a great example of abstraction. All of the complexity going on when you go to www.google.com and it's trying to figure out where to find Google. It has to determine everything going on there. It has to send requests for the data, get it back, and then render it onto your screen. And for you, all you had to do is type in a simple web address. So abstraction is just a really fundamental tool in programming. You want to try and keep as much of the detail away from you at any point in time as you can, because if you try and think about everything all at once, you're never going to get anywhere. The next big concept here is algorithms. Someone explain to me what an algorithm is. Any guess? Any, take a shot in the dark. What? Instructions? What? Logic? A math equation? Yeah. All of those are great examples. So an algorithm is just a process or set of rules or instructions that can be followed to solve a problem. So we've already written some small algorithms. The difference between our methods, if we have the method find longest string, and the algorithm is that the algorithm is what we implement inside of that method to find the longest string. You can use a lot of different algorithms to find the longest string, and yet you can abstract those away with the method, and it doesn't matter what algorithm you're using. But algorithms are hugely important in computer science and programming. If you went to university or a school to study it, you'd have entire classes devoted to just learning how to implement certain algorithms and what the complexity of those algorithms are, how long it takes for them to run, because it can make a big difference when you're working with data, say at the scale of Google, whether or not it can run through that algorithm quickly or whether it's going to take a really long time. And some real world examples of algorithms would be recipes are a great example that we've all used at one point or another. It's this set of instructions. Cut up the onion, put it in, cook it for 5 minutes, cry a little bit, throw the rest of the food in, etc. Recipes are a great example of algorithms. But we also have algorithms for even other simple things that we do. I'll bet everyone follows some simple algorithm for how you tie your shoes, whether it's make 2 bunny ears and tie them around each other, or loop, swoop, and pull. You people who are able to do that, I'm envious. I was never able to do that. We've got algorithms for how you drive to work or school. That might just be a personal algorithm. It's, well, I'm going to take a right, and then I'm going to take a left on Maynard, and I'm going to get stuck going around in a circle because I forget that it goes in a loop and carry, and I'm just going to have to take a right at some point to get off. And we have real world or in code examples such as sorting an array of numbers. That's a very common example of an algorithm that you'll encounter, and there's not just one algorithm to sort an array of numbers. There's a huge collection of algorithms on how can I sort information. And they have varying ways to be implemented, varying complexity, varying speed of execution. And there's just entire fields of study in computer science on how do we create algorithms that are efficient and accomplish what we want to accomplish. So another fundamental concept for computer science is the concept of composition. We talked about abstraction, being able to abstract away a lot of complexity. Composition is a little bit the opposite. Composition is using smaller, simpler pieces to create something that's more complex. When you're writing software, you really want to make small pieces that you can build up into something bigger, so that each one of them only does one simple thing and can be reasoned about very easily. And then you can put them together and build very, very complex programs. So some real world examples of composition. A symphony is a great example of composition, not only because it's what jumps to mind if you're thinking of composition, but a symphony is a whole bunch of individual instruments that each have their one set of notes that they're playing, and when it comes together, you get something much more complex out of it. And even breaking it down more, the individual instrument is looking at a piece of sheet music that's a composition of notes that are all individual and put together. But when you, again, bring these small pieces together, you get something much more complex out of it. And I think a great example of composition when you're thinking about computer science, when you're thinking about programming, are Legos. I think of them, I mean, Legos let you build from very, very small building blocks something that is incredibly complicated and can accomplish a lot of things, but you didn't have to have huge pieces to do it. You had these very small individual pieces that you put together and ended up with a very large, complicated machinery coming out of it.
It would be a cool job to have. My God.
But when you're thinking about writing code, especially larger programs, Twitter, even if you're thinking larger ones relative to anything that you've written so far, a tic-tac-toe game, a game of Battleship, a card game to be able to play blackjack. You don't want to write that all in one function. You don't want to write that all in one method or have everything together. You want to compose a whole bunch of small pieces together that you can then think about individually, so you don't have to try and imagine your entire application at one time. And once you can think about those small pieces, you can build them up into larger ones. This is a set of skills, learning these tools, how to compose small pieces, how to abstract away complexity so I don't have to work with it all the time, how to write algorithms. That's really what we've done a fair bit of so far, are algorithms to accomplish things. Now we're getting into the phase where we're going to use some of these other tools, composition, abstraction, to help us build larger programs and accomplish just much cooler things. It's really, those are the concepts I was hoping to introduce today. And as you're writing code and thinking about code, I really recommend thinking about how to break stuff down in this way. We'll definitely go through examples in the second half of this course of slightly more complex programs and how to break it down into smaller pieces so that you can think about them.
It's kind of like solving a math problem. You know, big, complicated math equation.
Right. Yep. Yeah, it's like solving a big math equation, how you have to break it down and solve smaller pieces at a time, and then maybe bring those back together after you've solved them. It's a big challenge. I have been doing this for a long time, and I struggle with trying to break things down into small enough pieces. Now, I can't think about the whole at once, and if you try, you'll just get stuck spinning your circles because there's too many things to think about. Got to break it down into these small pieces and then bring those back together to build up something more complex over time. So I wanted us to have a break in the middle of this course so that you guys had a chance to pick up any of the concepts that we've talked about. We're not going to have any homework or anything to work on tonight or before Saturday. And then I just wanted to give you guys an opportunity now to, first, let me ask, are there any concepts that we've gone over that have really been a challenge so far that it'd be useful to go over again or work through in some of our homework? Anything people are struggling with?
I have a question. Last class, did you take a look at hashes?
You gotta look at hashes?
Yeah.
No, I didn't.
You did not? Oh,
I have not looked at hatches yet.
okay. So what did you take a look at last time?
We basically went into functions again and talked about them in more detail, and then I talked about scope and the concept of scope of variables, so that was more firmly ingrained. Like when does a variable exist? When can I reference it?
Okay.
Nobody wants to say, oh man, I've really struggled with functions or arrays, blocks, nothing? All right. I hope that's true. People aren't just being quiet. Then the next thing I would say is, are there any topics or any programming assignments that you really want to cover? Any programs that you think would be you really want to try and accomplish in this class? And I'll try and let you know if I think we can fit it in or if it's going to be too complex before we get to the end of it. I think people want to do. I think one of the last things we're going to try and do, just so you get a scale, is I need to look over it. We're going to try and create a battleship style game. I need to make sure that we have all the details for that because that's pretty complex, but I think that's what we're going to try and get to, is being able to create a battleship style game. So we might build up over the last couple weeks the pieces to do that. Anything other people think would be really fun?
I love Sudoku.
Sudoku.
Yeah.
Ooh.
Also, we're getting a game, thinking game ideas.
Well, or just programs. If there's something that you think would be, we could do something. I can throw out ideas, right? Ones that are reasonable for us. Here's one that you guys could do right now with what you know. It would be useful if I teach you how to do input. But one that you guys could do right now could be something like oh man, I'm going to spell this wrong, aren't I? Caesar cipher. Does anyone know what a Caesar cipher is? The Caesar cipher is very, very simple. You take a string, you take a word that somebody said, and you encode it by shifting each letter 13 letters forward in the alphabet. And if you reach the end, you wrap back around to the start of the alphabet, and then you return that string instead. And then you can decode it by just shifting it back 13 letters in the alphabet. It's called the Caesar cipher because, at least by legend, Julius Caesar used it to encode messages. But that's one that we could write. And you pretty much have the tools to accomplish that right now. Getting input from a user would make it easier, but something we could do. Or other similar ones. We could do Pig Latin.
It's like, isn't that talking back? Or it's like a film?
I remember doing it in middle school. It's something like with the first letter.
Put it back or
Like,
it's
In Pig Latin here. Somebody's going to explain it better than me. So
It was so popular when I was like, it's like something. Etsy.
what's that?
It's clean, it's fresh, and I'm living every second of it. So thank you so much for the best thing. If you want to check it out, you can find that link in the description box below.
Wow.
You'll leave us one of the videos. Now, I'll break the history behind because they don't want to say everything. But all I know is that's really old language, which is code. But you know that every class, another that
You're awful. I can't even hear you. Let me just look up.
Yeah.
I'll bet Google. made-up language formed from English by transferring the initial consonant or consonant cluster of each word to the end of the word. So like ixnay. Or pig would be igpay. Because you took the IG off and you added the AY, moved them to the front. Igpay, atinlay. You know, it's very possible for us now to write a program that would with what we've learned. Any other thoughts or ideas?
Are you gonna try to do all those right now?
No, I'm just saying these are things we could do. All right. So then, I don't know. Are there any other questions that people have up till now on what we've covered or what we're going to cover? The next class? My intention right now is to introduce classes, objects and classes in the next class, which is another abstraction. You can start thinking about it now, but it's a way to put a whole bunch of behavior of something together. You tend to hear examples in the real world of something along the lines of you may have an animal class, and an animal has certain properties. What are some properties of an animal? Fur. Eyes, legs, paws, color. And an animal may have certain actions it can take. It might eat or talk or blink, I don't know. And so that tends to be a very common reference of classes. We'll probably use an example like that. Animals, vehicles, something similar.
Is there inheritance in them?
Yes. Yeah. I don't even know if you could call it classes, at least not classical object-oriented programming without inheritance. But yeah, so the intention will be to introduce classes and work off of that. Then maybe we'll go back and do hashes and getting user input. Might be a good thing to pull in after that.
What are hashes?
What are hashes good for? Hashes are another object type. We've already seen a lot of those, such as arrays and strings and Boolean numbers. Hashes are an object type. If you want to think of them, a real world comparison, probably the easiest thing to think of is the phone book, for anyone who's actually seen a phone book here. Or a dictionary are both really good examples. A hash it's like an array, except instead of items being stored by an index number and just in a specific order, you don't reference them with an index, you reference them with their key. And for example, in a dictionary, the key to get the description or the definition is the word. I need to look up aardvark. So I look for aardvark, knowing where the key is, and it helps me get to the word. I look for potato, and it gets me to the definition of potato. A phone book's the same way, except in a phone book, the key is the user's name, the person's name, and the value is their phone number, and maybe their address. So hashes allow you to store stuff with known keys and then access them with those keys again later. They're really, really useful. They're actually, in some programming languages, hashes and objects are not even distinct from each other. But hashes let you do a whole bunch of really powerful things. So let's say I am I'm trying to think of a really good example off the top of my head here. But let's say I'm trying to find, this is a little weird, but I want every word that begins with R. I'm making this a little more complex than it would be otherwise, out of a string. Or I want to be able to find every word that begins with each individual letter out of a string. So I may use a hash where the key is the letter and the value is an array of words. And I'll go through that string looking at each word, find out what that it starts with, and then put it in that position in that hash so that I can now get all of those words very easily. Put me on the spot. There's so many uses for them. I should be able to come up with 100 off the top of my head, but I don't have them right now. Yeah, I don't know. I use them every day. All right. Any other questions? Anything else? Cool. Well, we're just taking it easy this day, so we'll be done, and I will see you guys on Saturday.